Hey, this is Alex Leinert. I'm coming to you from the Executive Briefing Center here at Microsoft, and I'm here to talk to you a little bit about phishing-resistant credentials and the importance of that, and the kinds of attacks we're seeing and the identity protection team here at Microsoft, and some things that you can do about it. The situation that we kind of swim around in, the oxygen we breathe, is password-based attacks, and we still see many thousands of these every second, right, that we're deflecting at Microsoft. We're defeating many password-based attacks, and unfortunately some get through. And the reason for that is that people are still using passwords, and passwords are just intrinsically super easy to defeat. So everything we're going to be talking about here in terms of the importance of phishing-resistant authentication is super important, but it doesn't in any way say, well, you get to not worry about passwords, right? We're going to still do that. The good news is that all the stuff we'll do for phishing-resistant authentication will defeat all the password attacks as well. So if we kind of go back in time a little bit to around 2017, we had almost no multi-factor auth adoption. And through, I think some good motivation coming from bad attackers and, the migration to a lot of remote work due to the pandemic, and then a bunch of programs that we put in place like security defaults and managed policies, we've seen that number rise since 2017 to about 40%. It's a little over 40% now. And so attackers did not retire and hang up their hats and go get honest jobs. What they did is they started moving up the ladder in terms of attacks. So initially, since everybody's just using password, you go to the lowest amount of energy you can spend, and you just attack passwords, password spray, phishing, breach replay, that sort of thing. And then you kind of go up the stack a little bit and you say, all right, well, if the person that I'm trying to attack is using MFA, hopefully they're using lame MFA like SMS or simple push notifications, and those things can be defeated in various ways. And so where we get to a place is that if you're a target of interest, it's not just that you're using MFA, it's that you're using the right MFA. And the right MFA is phishing-resistant MFA. When we look at the kinds of things that can happen on a simple push approval, you can just keep making requests to the user over and over again if you have their password, and eventually they'll get sick of it, right? And in some cases, you don't even need the password. And eventually they get sick of it and they'll just say approve. And so that's what we call an MFA fatigue attack, and that's a problematic attack. So we put different pieces of information in the authenticator. We put number matching in the authenticator to defeat that attack. And then we see people go the next level up, which is that I want to socially interact with you or trick you into clicking a link. And the thing about this is that ultimately, we can put as many helpful hints into the process as we want, but we have had cases recently of, for example, people getting text messages that just simply say, not from a number they know, just from a random number. Hey, this is tech support, and I'm working on your account. I need you to enter the number that you're, this number here into your authenticator app. Open your authenticator app, enter this number into it. And people will do it, right? Because they just sort of assume they don't really understand the account system, and they fall for that. Other cases, so that's kind of a simple social engineering attack. Other cases where, links get sent out and you click on the link and the website you're interacting with is replaying all the UI back to you. So from the interaction perspective, you're seeing all the right screens, you're seeing the request for the number, all that stuff is happening. And once you've clicked past that warning that says, hey, this may not be the site you think it is, the rest of it is fair game. And again, as much as we'd like to say we have the UX hints and training and posters in the elevator that help with that, there's always going to be somebody who's curious about what's behind that link and is going to click it. And once they do that, along with the normal malware kind of problems, you're going to have this problem of interacting with a website that's pretending to be the correct authentication website. And as a result, that replay, that sort of adversary in the middle, replaying the UX back and forth, allows the adversary in the middle to trick the user into, again, entering the codes or doing the interactions they want to. And so when we talk about phishing-resistant auth, we're talking about authentication methods that don't allow for this. And the two major characteristics that we're looking for is, one is that the user has to have proximity to the device that is trying to authenticate. So we're going to grant a session token to a specific device. We want to know that the user is present at that device. So the user presence test is one of the major things that we're looking for. And the second thing that we're looking for is that there's a relationship between the website the user is interacting with and the credential that's in their hand. And so these are sort of the kind of the core principles around phishing resistant authentication. We have that proximal device, and we also know that the credential we have is bound to the thing we're trying to authenticate into. So let's talk about in a sort of phishing attack why those two things are important, right? In a phishing attack, what's happened is I have an adversary, they've set up a server somewhere, and it's probably not nearby, right? It's probably in their region, and they've got it on some, anonymous VPN or whatever. And they're tricking you into logging into it. And they do that by saying, hey, check out this cool video, or can you believe what Alex did last weekend? He was acting crazy. Come see the video of it, or whatever. They find a way, or urgent, you have to do this, or we're going to take away your credit card. Whatever the thing is that is the incentive. But they create that urgency and that interest, and then they get you to click on the link. So now what's happening is you are, in your office, interacting with a server that's way over there on somebody else's bad guy infrastructure, right? And the bad guy's job is to get a token onto that device that they control, right? They can't do it unless you give them the power to log in. So what do? Well, you click on their server comes to our server, gets all the UI, and just plays it back to you. So you think you're seeing essentially a login server at that point. And you respond by typing in your username and your password, say, and they send all that information along to us, and we respond by saying, hey, we don't think this looks like you're coming from the right place, so we're going to challenge you, right? So it comes back to challenge, and it says, hey, enter the number you see here on the screen into your authenticator. That goes back to you in your normal place, and then you enter it because you've been tricked, right? That's the way a phishing attack would work. But if we can say the user has to be next to the machine that's actually signing in, right, and that whole process falls apart for the attacker. Like just that step by itself, right? If I have to be right there, it means that now the attacker infrastructure has to be right next to me, right? Like they could do this phishing attack where they have to launch it from my own laptop, right? But the second part is also important, because the second thing is that we will only release a credential in phishing resistant to the thing that it's registered to, right? And so that's just a simple URL check. So the very first time I sign up to say, it's login.microsoft.com or whatever, right? I'm issuing that credential to that environment for a specific account in that environment. When I have that, essentially, if an attacker sits in the middle, the URL won't check out, right? Like the credential, the authenticator goes up to the URL of the attacker's infrastructure, and it looks at it, it's like, well, that's not login.microsoft.com. So I'm not going to release my credential. I won't even interact with it. The two things, and this all together kind of creates this thing, which is verifier impersonation resistance. And that, in turn, is sort of a heart and soul of the FIDO standards, which are used in passkey, right? So there's different ways to do phishing resistant. I'll talk about that in a minute, but they all have these characteristics, which they're creating this user proximity, and they're making sure that we have an authentic interaction going on. And those two things together don't rely on the user's choices to keep them safe from phishing. And that's really important, right? Because what we know is that when we rely on the user to make safe choices, we usually get disappointed, right? And even if most of the users are great, it takes one in a big batch and you get a breach. So the whole point of these phishing resistant credentials is to take that question mark of, can the user be social engineered? Can they be tricked into clicking on a link? And take that out of the equation and say, hey, the credential itself just doesn't work unless it's the user interacting from their own device and with a site that they've interacted with before. Those things all have to be there. The user's present, right? They're right there at the device that's signing in, and they're signing into something that they've already registered that credential for. So they can't be tricked into giving up their credential to an attacker site that then replays it. It's not replayable. So that is sort of the heart and soul of like what we're doing with phishing resistant. In terms of your options, you got a bunch of options. I mentioned the FIDO2 specifications before, WebAuthn and CTAP. And the key here is that these are built around these standards and built to be secure credentials. Windows Hello is a host for these things. When we talk about a credential of this type that is implementing the FIDO2 standards, the credential, we call those passkeys. Okay, and they have different flavors. And so whatever it is you need to do, like you can do it with a passkey. Like when you have the physical security token, FIDO security token, the things that are on that, the actual credentials are called passkeys. When you have your consumer device, like your Android or your iPhone, and you're signing in, to a consumer site with that passkey interface, that's actually, again, implementing the FIDO standard. It's all building on this kind of security. The Authenticator app is now in public preview with passkey support, or will be by the time you see this video. It's in a couple days. And So the Authenticator app will host a passkey. And so if you already run the passkey or the Authenticator app out in your environment, you can very quickly convert that so users can do it on their phone, or you can buy a security key. So you have lots and lots of options for how to do that. And that's kind of our recommended way of dealing with phishing resistant auth. Windows Hello, when you do the interaction with Windows Hello, like the face check or the PIN, and you're signing in that way, Windows Hello is also a passkey host, right? So you can set up your passkeys on your Windows Hello device. And so you can sign into whatever website you need to, or to us in this phishing resistant way, right from your Windows device using Windows Hello. You can do it from your phone with the Authenticator, or you can do it from your phone with the platform stuff. In Entra, that'll be coming soon. It's not yet. So right now, for using your phone, you're going to use the Authenticator app. But that's not the end of your options. For many, many organizations have been kind of more security forward for a while. And the way that you did this stuff before was cert-based authentication, right? So if you have a PIVCAT card, you want to use that card to sign in. We also support that. And that is also a phishing resistant method because the card has to be present, because you're doing the cert interaction right on the client device. And that cert is for a specific resource. All of that meets all the standards that we need to meet for phishing resistance. So now we've got lots of options, right? We've got the Authenticator app, we've got physical security keys, we've got Windows Hello, we've got cert-based auth, and coming soon we'll have these platform-based, like the ones that are built into the phone. I won't get into all the nuances of like there's syncable and device bound, and there's advantages to both. And we can, there's a blog coming out that'll talk about that. But the most important thing for you to understand is you can get to phishing resistant authentication now. There are plenty of options to do it now. And then critically, the attacks that rely on social engineering and adversary in the middle are on the rise in the face of this increase in MFA, because those attacks can defeat MFA. So it's not just that you're doing MFA, it's that you're doing the right kind of MFA. And the right kind of MFA is phishing resistant multi-factor authentication. That's where we're trying to get everybody to go. We're making that extremely easy by building it into Windows, building it into the Authenticator app, supporting it in Entra, giving you options to go with your existing infrastructure with cert-based auth. Tons of options for you to go with. Very important to start moving in that direction, because the attacks in this space are on the rise, and the only way to really defeat this is to take the social engineering question and the did I click the bad link question out of the user's hands and support an authenticator that's easy to use but doesn't let them fall into those traps. All right. I hope you enjoy the series, and I'm grateful for your time today, and I hope you have a good, safe digital journey using phishing resistant auth.